In this video, I will explain the 3 most common misperceptions about YOLOv8. But before that, I will show you 3 interesting facts about YOLOv8 you don't want to miss. First, YOLOv8 is much more popular compared to the 2 newer YOLO models, YOLOv9 and YOLOv10. Google Trends shows that over the past year, interest in YOLOv8 has been much higher than in YOLOv9 and YOLOv10. In addition, in the videos about YOLO architecture that I have made, views on the YOLOv8 architecture video are much higher. Second, the community is very active. There are more than 300 contributors on Ultralytics YOLOv8 GitHub who are also participating in answering your questions. Even Glenn Yoker, the main author of YOLOv8, often answers directly the questions on GitHub with a very detailed answer. Third, YOLOv8 is user-friendly for developers. YOLOv8 provides a complete documentation designed to help you understand and take advantage of its features and capabilities. Besides that, YOLOv8 can be run using the command line interface or CLI and can also use Python code. Now, let's talk about the 3 most common misperceptions about YOLOv8. Beforehand, to get updates on YOLO and computer vision, click the subscribe button and don't forget to ring the bell. Okay, the first misperception is the definition of object sizes on YOLOv8 or in YOLO in general. There are 3 sizes, which are small, medium, and big objects. The object size is relative to the image or the video frame dimension. For example, a sperm cell in the real world is a small object. However, the same sperm cell can be considered as a small object or a big object, depending on its appearance in the image or video frame. Second, the image size or IMGSZ hyperparameter. If you read the textbook and we comprehend the role of IMGSZ hyperparameter in YOLOv8, it is actually the input layer resolution. For example, when you set IMGSZ equals 640, you don't have to resize the images in your dataset to 640 by 640. YOLO will resize your images automatically. In YOLOv4, the image will be resized exactly to 640 by 640, which will change the aspect ratio of the images. In YOLOv8, the image will be resized to 640 by 640 with the aspect ratio maintained by adding gray padding, in accordance with what was conveyed by the author of YOLOv8, Glenn Yoker. Third, the YOLOv8 variants. There are 5 variants: YOLOv8N for nano, S for small, N for medium, L for large, and X for extra large. The variant does not mean that to detect small objects you can only use YOLOv8S or YOLOv8N. All variants can be used to detect different sizes of objects. The variant indicates the size of the architecture of the variant. Thus, YOLOv8S has a small architecture, which means it has less number of parameters and runs faster, but the accuracy is not too high. On the other hand, YOLOv8L has a larger architecture with more parameters, which make it more accurate than YOLOv8M, S, and N. Unfortunately, the computational cost is higher, which makes the inference process slower. Now, you know the 3 most common misperceptions about YOLOv8. If you like the video, just hit the thumbs up and the share button. If you have any question, please feel free to put it in the comment section. Thanks for watching.